Hello everyone, welcome back to the channel. In this video, I am going to discuss limit chapter questions from Black Book. So let's see. First question is limit x tends to 0 cos of 10x minus cos x upon x to the power 4. So here you can see this is on applying this limit. It is coming 0 by 0 form. Right now it is a 0 by 0 form. So let's solve it. Here 0 by 0 form we cannot apply hospital rule. It is time wasting only. Correct now. So we are going to use here factorization method. So for that, here you can see this is cos C minus cos D formula can be applied here. So limit x tends to 0. We are using cos C minus cos D. So that is 2 sin C plus D. So C is 10x, D is x by 2 into sine of D minus C. So x minus 10x upon 2 whole upon x to the power 4. Whole upon x to the power 4. So 1 upon x to the power 4 we can write down in that way. Why I am writing? Why? Because here I am just going to multiply in the denominator tangent of x plus x upon 2 into x minus tangent of x upon 2. And here same thing we are multiplying in numerator also. So whole upon x to the power 4, that's why we are writing here. So that is tangent of x plus x by 2 into x minus tangent of x by 2. Right? That it is. Whole upon x to the power 4 it is written here. Clear? So why we have done this? Why? Because we know one frequently used limit is there. That limit is if limit x tends to a, sine of fx upon fx where x approaches to a, fx approaches to 0, then that limit will be equals to 1 here. Correct na? So using this frequently used limit, if we are treating this tan x plus x by 2 as fx, so you know sine of fx upon fx, x approaches to 0, tangent of 0 plus 0 by 2, that is 0 only. So that is becoming same here. Sine of 0 by 0 form, correct? That will be equals to what here? 1 here. So we can say that is nothing but that quantity is equals to 1. Similarly, if limit x tends to the sine of x minus tan x by 2 upon x minus tan x by 2, if fx we are treating this one, so we know that that is also becoming on x approaches to 0 as 0 only, correct? So sine fx upon fx where fx approaches to 0 is what here? That also equals to 1 here. So that quantity also I am just saying as 1 only, correct now? So I am just using this frequently used limit. So here you see that given quantity can be written as on sending this limit on these two parts. So we can say this is 2 constant as it is, and using limit on this part, so that will be 1, and using limit on this part, that will be also 1, and limit is going on this part, so that is limit of x tends to 0. And now from here you can see this is tan x plus x by 2. This x to the power 4 here only I am just going to write down as a factor of x and x cube. So we can write down x into x cube like that. Correct? Now I am using this x in the denominator of this and x cube in the denominator of this. So that will becomes here. Since 1 by 2 is coming as a constant here, so 1 by 2 as it is. And now here you observe tan of x upon x plus x upon x, and if you are observing this one part, so this one part you can see that also 2 is a constant, that 2 also we are taking outside, so 1 by 2 one more is coming here, that is x minus tan x upon x cube, right? That it is. Now from here you observe this 1 by 4 it is becoming, it is coming outside, so that is nothing but 1 by 2 only. And here if you are seeing tan x upon x, x approaches to 0, that quantity, this given quantity is becoming what here? 1 only. And x upon x, x approaches to 0, that is also what becoming here? 1 only. So that is also 2 here. So here 2 into 2 into 1 by 2, 1 by 2. So overall that will be what here? We are writing here just simply 2 into 2. 2 into 1, that is understood, 1 by 2 into 1 by 2, and this given quantity overall is becoming 2 here, that is written there, right? And then limit is going on that part, limit x tends to 0. Here you know this 2, this 2, this 2, this 2 get cancelled here, there is no meaning of mentioning it also, so no need of mention that one, clear na? So I am just removing this to keep minimum thing on the screen, limit x tends to 0. Now overall this thing we have to focus, limit x tends to 0, x minus tan x upon x cube, x minus tan x upon x cube everybody. So what will happen from here? Again you can observe, this is what here, this is again 0 by 0 form, 0 by 0 form. So here either we can use tan x expansion, then we can solve, or we can use here L'Hospital rule. Here L'Hospital rule will be not time consuming, so we can use Hospital rule here. So what will happen, just observe, using L'Hospital rule, limit x tends to 0 and this given data is numerator differentiation with respect to x 1 minus tan x differentiation secant square x upon x cube differentiation 3x square, right? Now that it is. And now x tends to 0, x tends to 0 means what here? Secant of 0 is what here? 1. Secant of 0 is what here? 1 here. So 1 minus 1 0 and denominator also 0. Still it is in the 0 by 0 form. Still it is in the 0 by 0 form means what here? Hospital rule again we can apply here. So limit x tends to 0. So what it will happen here? Minus of 2 times secant x and then secant x differentiation secant x tan x. So secant square x into tan x, right now. First, with respect to power, we are doing differentiation of 2 into secant x and then secant x differentiation secant x tan x. So that will becomes again secant square x into tan x, right? And whole upon 6x, right? 2 3 are 6x. Now here x tends to 0, tan x upon x. Just focus on that one. That is again standard limit, standard frequently used limit. That is what here? That is equals to 1 everybody, that is equals to 1 only. So not no need to mention here. So that will happen. So what here, just observe, that is minus 2 by 6 and then secant of 0 square, secant 0 is 1, so 1 square it is only, and tan x upon x, x tends to 0 is 1 here. So that is becoming what here? Minus of 1 upon 3 everyone, minus of 1 upon 3. So which option is correct here? B option is absolutely correct. Next question is, let a is equals to limit x tends to 0 ln of cos 2x upon 3x square and b is equals to limit x tends to 0 sin square 2x upon x into 1 minus e to the power x, and c is equals to limit x tends to 1 root x minus x upon ln x. Then a, b, c satisfy which one order? Okay, let's see here. So if we are going to observe, limit x tends to 0, ln of cos 2x upon 3x square it is given here. So we can write down this one as ln of cos 2x. We can write down 1 minus of 2 sin square x, right, upon 3x square it is written here, correct? Upon 3x square it is written here. So we can write down here this 3x square here, and here we are writing minus of 2 sin square x, and here also minus of 2 sin square x, right? Now in numerator denominator both we had done multiplication. So now you know there is a standard limit, limit x tends to a ln of 1 plus fx upon fx, where fx tends to 0 will be equals to what here? 1. So using this frequently used limit, we can say this one part is nothing but 1 only, correct? Na? So using that one we can say that is nothing but 1 only. Why? Because fx is 2 sin square x. When x approaching towards 0, this fx 2 sin square x is becoming 0 here. So that we can write down directly, that is nothing but 1 only, this part, right? So just observe here. So that means a is equals to, that quantity is 1, and then this given quantity limit x tends to 0, and this is minus of 2 by 3 and sin square x upon x square. So x tends to 0, sin x upon x, already I said it is also a frequently used limit. When limit x tends to 0, that is equals to what here? 1 only, correct? So here you can say this sin square x upon x square is what here? 1 only, correct? So no need of mentioning this, directly we can write down this part is becoming 1 and this part is becoming minus 2 by 3 into 1. So minus 2 by 3 into 1 we can write down completely, right? So that will becomes what here? Minus of 2 by 3 everybody, minus of 2 by 3. This is a value everyone. A value is minus of 2 by 3, right? Now from here you can see b is what here. So b I am just going to solve here, just observe the b. So b is given here, limit x tends to 0, and that is sine square 2x upon x into 1 minus e to the power x, right? So here also observe what I am going to do, limit x tends to 0, and then this is sine square 2x. So here square is there, right now, and here 2x is there. So what I am doing here already x is there, just I am doing 4x multiplication in denominator and numerator both. So everybody 4x we had multiplied, x already there, so 4x into x, 4x square, right everyone? And now 4x we had multiplied in numerator also, here it is written, and this given quantity 1 minus of e to the power x, here in this denominator of 4x I am writing. Any problem? No problem here. So that can be written 4x square is nothing but this given quantity, you know, that is here 2x whole square, and sine square 2x means sine 2x whole square. So we can say this meaning is nothing but whole square only. Just I am writing in a very basic manner so that the student who are doing first time limit chapter from this book, who are in first years, especially in south, they can also understand it very well. So limit x tends to 0, this is sine of fx upon fx. You can say x tends to 0 or x tends to a, and fx tending towards 0. So that is equals to what here? That is equals to 1 only. Already I said frequently use limit in previous question also. Here also in this part. So here that will becomes 1 here to the power 2. So that is what here? 1 only everyone. That is only 1 here. Right now? So using this we can say this is nothing but 1 square. Right? This limit will go inside this. Then this is coming 1. So its square is 1 square, which is 1 only. Correct? 1 only, and also this is becoming 1, and also focus on the here limit x tends to 0. Here only observe limit x tends to 0, and 4 as a constant we are taking outside, x upon 1 minus e to the power x it is, correct now? So one more frequently used limit is there, that is limit x tends to 0, e to the power x minus 1 upon x is nothing but 1 only. Everybody is standard frequently used limit here. So in that way, if you are seeing this minus, if we are taking common here, correct now, this part minus if we are taking common, so minus 4, so that will become e to the power x minus 1, e to the power x minus 1, and this x means you can understood here that it is meaning here, so limit will come in denominator part, that is 1 here, so 1 upon 1 is what here? 1 only, and this is minus 4, so minus 4 into 1 is what here? Minus 4 into 1 is nothing but minus 4 only everybody. So can I use directly this b is equals to minus of 4, right now? That it is a value minus 2 by 3, b value minus 4. Now I am going to clean this, right? Now let's see the c part. C part is saying c is equals to limit x tends to 1, x tends to 1, root x minus x upon ln x. So here we can take root x in the numerator common here, root x common here, so that will be 1 minus of root x upon ln x, right now? Ln x. Now from here you can observe x tends to 1, x tends to 1, so this root of 1 is what here? 1 only, so that will be 1 here, 1 minus root x upon ln x, it is coming just. So we can write down that is limit x tends to 1, 1 minus root x, 1 minus root x upon ln x, right? So from here it is coming in the 0 by 0 form, 0 by 0 form. So easily we can apply L'Hospital rule, correct? L'Hospital rule when we are applying here, so what will happen, just observe, when we are applying L'Hospital rule, numerator differentiation when we are doing here, so what will happen, so 1 differentiation 0 minus root x differentiation 1 by 2 root over x, right? And denominator differentiation when we are doing, so that is 1 upon x here, clear? So this quantity will become here limit x tends to 1, and this given data, if you are seeing here, this is coming here, x minus of x upon 2 root x. So when x approaches towards 1, so that is nothing but minus of 1 by 2. So c is equals to minus of 1 by 2 we are getting. C is equals to minus of 1 by 2 everybody. So from here c is equals to minus 1 by 2 when we are getting here. So which order satisfy here? So here you can see A is minus 2 by 3 and B is minus 4 and C is minus 1 by 2. So in A, B, C, smallest is B here. So here we are getting B is smaller than both quantity, and among these two if we are seeing a C and A, so minus 1 by 2 and minus 2 by 3, the smaller one is minus 2 by 3 because of the negativity sign, correct now? So B is smaller than A and A is smaller than C here, right everyone? So this order is correct everybody. So B is less than A is less than C. So our D option is absolutely correct. Next question is, if fx is equals to cot inverse of 3x minus x cube upon 1 minus 3x square and gx is equals to cos inverse of 1 minus x square upon 1 plus x square, then limit x tends to a fx minus f of a upon gx minus g of a, where a is in open interval of 0 to 1 by 2. So a is in this interval everybody. So for that one, this given quantity fx, which is cot inverse of 3x minus x cube upon 1 minus 3x square, since here this given data we know that when x is approaching towards a and a is in the limit open interval 0 to 1 by 2, that will be nothing but pi by 2 minus 3 times of tan inverse x everyone, right? That it is. And similarly, if we are observing on gx, so gx is cos inverse of 1 minus x square upon 1 plus x square. So we know that when a is in this interval, we can say that is nothing but 2 times tan inverse of x everybody. That is our gx here. Clear? So now we are going to evaluate this limit here. So just focus on this. So this limit will becomes what here? So limit x tends to a, fx minus f of a, fx is pi by 2 minus 3 tan inverse x, right? Minus f of a upon gx minus g of a. So gx is 2 tan inverse of x minus g of a. G of a is nothing, just as a constant only, since a is in this interval. So g of a will be some constant only, this only, correct? So that only I am mentioning here. So here you can see when x is approaching towards a, so what will happen here? This given data will becomes here pi by 2 minus 3 tan inverse of x here, which is fx only, correct? So here either you mention this or you don't mention. You know this quantity is coming here. This is nothing but f of a only. This is nothing but f of x only, correct now? So means what here? This means is limit x tends to a, f of x minus f of a upon, this is what here? G of x only. So g of x minus g of a. So when we are putting this limit x is equals to a in this one, so f of a minus f of a and upon g of a minus g of a, so it is becoming 0 by 0 form everybody. From this one you will be observing, so it will be complicated, but if you will consider that this is nothing but f of x only and this is nothing but g of x only without putting these functions, so we are getting this one. So we will directly do our limit evaluation from this one. This meaning is this only, correct? So it is 0 by 0 form already, as I said here. So what we will use here? L'Hospital rule. L'Hospital rule when we are using, so limit x tends to a. L'Hospital rule, numerator differentiation with respect to x, so that will be f dash of x minus f of a. F of a is what? Constant, its differentiation 0, so no need to mention. Upon g of x differentiation g dash of x. And g of a is a constant, its differentiation is 0, no need to mention. So we are getting this. So from there we are getting limit x tends to a, f dash a, f dash a upon g dash a, we can say, on using this limit directly we can say that is nothing but f dash a upon g dash a, right everybody? Now everyone, from this one part if you will see, fx is this, so what about f dash x? F dash x, if we are talking about, so pi by 2 differentiation 0, minus of 3 tan inverse x differentiation 1 upon 1 plus of x square, right? Here observe, gx is 2 tan inverse x, so it's a differentiation g dash of x, we can say 2 upon 1 plus of x square, right? So this we are getting here. So from there we can say f dash of a is nothing but minus of 3 upon 1 plus of a square upon g dash of a is nothing but 2 upon 1 plus of a square. So 1 plus of a square, 1 plus of a square getting cancelled, minus of 3 by 2. Minus of 3 by 2 is the correct answer for this question, everybody. Next question is limit x tends to 0, 1 plus x to the power 2 by x upon e square whole power 4 by sin x. So this one can be written as limit x tends to 0, and this given quantity inside this bracket can be expressed as e to the power log base e of 1 plus x to the power 2 by x upon e square and whole power 4 by sin x, right everyone? So that doesn't make any difference in the meaning, clear? Now we are going to use here logarithmic property, that is here log base e of m upon n is nothing but log base e of m minus log base e of n, right? So using this property, this given data we can express as, just observe this, that is limit x tends to 0. So using this property on this one part, as already I said here, so that is here e to the power, that is nothing but log base e of 1 plus x to the power 2 by x minus log base c of e square, so that is here nothing but 2 only. Here one more property is there, log base e of m to the power alpha is nothing but alpha log base e of m. So you know log base e of e square will be coming in the subtraction, so 2 will be power will be coming here, log base e of e is what, 1 only, so 2 into 1 is 2 only. So we can write down like this, clear everybody? And whole power 4 by sin x. Now using the second property only, this 2 by x will be also coming here as a product, right? So 2 by x we are taking in a product here, so x just I am writing in the denominator of this, and 2 is here. So 2 is common among these two terms, so 2 we are taking common also, that can be written as 1 only, clear? Now if you will observe this given quantity, so that is turning towards 1 to the power infinity form. If you will see x approaches towards 0, so there is a standard limit, standard frequently used limit, that is limit x tends to 0 log base e of 1 plus x upon x, that is nothing but 1 only, everybody, that is nothing but 1 only. So 1 minus 1, 0, 2 into 0, 0, so e to the power 0 is 1, so this part is tending towards 1, and 4 by sine of x, x tending towards 0, so that will be 4 by 0 is tending towards infinity here, 1 to the power infinity form is it is, right now? So 1 to the power infinity form, how to solve? Working rule we know very well, the given quantity can be expressed as, whole thing we will write down having base E. So what will happen, just observe, whole thing having base E we are writing, this entire this thing, and the quantity which is tending towards 1 means this entire value is tending towards 1, e to the power of 2 times of this given quantity. From that quantity we will subtract 1, so that will comes here e to the power 2 times log base e of 1 plus x upon x minus 1. So from this quantity which is turning towards 1, from that quantity we will subtract 1. So we are subtracting from this 1, and the quantity in the power which is tending towards infinity, which is 4 by sin x, we will write down in the product of this working rule for 1 to the power infinity form. We know very well, correct na? So that it is right. So now this is really very nice question. If you will see here, so here I am just going to use a logic here to convert this in a standard limit. What is that logic? I am seeing that this given quantity is on x approaches towards 0 is tending towards 0 here, right now. Log base e of 1 plus x upon x is what here? Tending towards 1 only. Already I had shown standard limit is, so 1 minus 1 is 0 here, so 2 into 0 is 0 only, so e to the power 0 is 1. So 1 minus 1 it is becoming here. Meaning is like there is a standard limit, that is limit x tends to a e to the power fx minus 1 upon fx. That will be equals to 1 if x approaches towards a. F of x is tending towards 0. So x approaches towards 0. So this given data is tending towards 0. Correct? No? That is tending towards 0. Correct? So what I'll do here, you know, this quantity is like fx here. So e to the power fx minus of denominator fx. So this quantity I have to write down in the denominator of this. So means denominator I am going to multiply by this so-called fx quantity. So same quantity we will be writing in the product also in the numerator. Correct? So let me clear this and then let's see here. This given quantity can be written as limit x tends to 0, and that is a e to the power, this it is e to the power of 2 times log base e of 1 plus x upon x minus 1. Right, everyone? Minus of 1 it is written. So this one's quantity denominator I am writing here. This one's quantity denominator just I am writing here. What we are writing in the denominator of this? In this denominator we are writing 2 times log base e of 1 plus x upon x minus 1. Right? As well as, if you will see here, same quantity that we had written in the denominator, same quantity we have to do multiplication in numerator. So that is 2 times log base e of 1 plus x upon x minus 1. So we are multiplying this quantity also in the numerator into 4 upon sin x, it is written here. Right, everybody? So that it is. Now observe. This quantity, as already said, this is our fx here. On x approaches towards 0, this fx is tending towards 0. So e to the power fx minus 1 upon fx on x approaches to 0, fx is tending towards 0 here. So that is nothing but 1 only. So e to the power 1 it is coming here. That is coming here. Limit x tends to 0. E to the power 1 it is. So on applying this limit on this part, that is nothing but 1 only. Correct. And this one part we are going to simplify. So 4 into 2 is what here? 8. That it is, and this one quantity we are just going to take LCM here, so that is nothing but log base e of 1 plus x minus x upon x sin x. Correct? Correct. That it is. Now from here you can see, on applying this limit on this power part, So this power is nothing but using fundamental law of limit, this limit will directly go on the power only, correct now? So it will go directly on the power. So this can be also written, just I am writing here for you, this can be written like this also, limit x tends to 0 here. So this power is tending towards 0 by 0 form, 0 by 0 form it is tending. So it means what? Yeah, Hospital rule we can easily apply for the calculation. So just I am using here Hospital rule. So what will happen, just to observe, using Hospital rule everybody, limit x tends to 0 and this it is 8 as a constant outside we are writing here, and this one part differentiation log basic of 1 plus x differentiation 1 upon 1 plus x and x differentiation minus 1 whole upon x sin x. So UV rule you can say of product of two function it is, so product of two functions, so chain rule we can easily apply here. So chain rule means two function product it is, so first function differentiation which is x, so it's differentiation 1 into second function sin x plus first function as it is sin x differentiation is cos x, right? So this it is. Now from here you can observe still it is converting on applying this limit in 0 by 0 form, isn't it? It is still converting, x will be 0 here, x will be 0, so 1 by 1 is what? 1 minus 1, numerator tending towards 0, denominator sin 0 0, x into cos x, x approaches towards 0, this is also 0, 0 by 0 form, again it is converting towards. So again one more time we have to use here Hospital rule. So Hospital rule one more time we are using, e to the power 8 limit x tends to 0 and this 1 upon 1 plus x differentiation minus of 1 upon 1 plus x whole square and whole 1 differentiation 0, its denominator sin x differentiation cos x plus x cos x, again product of two functions, so applying this first function x differentiation 1, second function cos x as it is, plus first function x as it is, cos x differentiation minus sin x, so that will be minus of sin x, right? So that it will be there. So from here you can see when we are applying this limit, so we are getting here e to the power 8 as it is, and when we are putting this limit x will be 0, so minus 1 upon 1 square, so minus 1, correct now, that will be minus 1 upon this quantity, if you are seeing here, that is minus 1 only, the numerator this entire value, and this quantity cos of 0, x approaches 0, cos 2 times, so 2 times cos, so cos 0 is 1 year, so 2 times cos, so 2, and this one x is 0 itself, sin also at 0, 0 will be there, so overall it is 0, so we are getting this only on simplifying this, on putting this limit, so we are getting e to the power minus of 4. So what is the limit of this question? Limiting value is e to the power minus 4. So which option is correct here? Let's see. E to the power minus 4. B option is correct, everybody. B option is absolutely correct. Next question is limit x tends to pi by 2 sin x upon cos inverse of greatest value of 1 by 4 3 times sin x minus sin 3x, right? So let's solve it. So limit x tends to pi by 2 and this is here sin x upon cos inverse of this given quantity 3 sin x minus sin 3x is nothing but 4 times sin cube x. So 1 by 4 into 4 times sin cube x, 4 numerator denominator getting cancelled, greatest integer of sin cube x it is coming here, right? Sin cube x. Now x approaches towards 0, everyone. X approaches towards x approaches towards pi by 2. X approaches towards pi by 2, so you know at pi by 2 it will be, sin will be always 1, right everyone? At pi by 2 it will be always 1. But when x approaches towards pi by 2 from left side, it will be tending towards 1. It will be not 1. It is approaching towards pi by 2 from left side. From left side, it means the value of sin x is also tending towards 1. It is not 1. Tending towards 1 means nearly 1, 0.99 something. Correct now? And when x approaching towards pi by 2 from right side, then also its value is not 1. Tending towards 1. 1 is this one. Correct now? Tending towards 1 means it is slightly smaller than 1. So 0.99 something. Correct now? So sin x value limit x approaches I am saying approaches towards pi by 2, not pi by 2. X approaches towards pi by 2, sin x will be approximately 1, not 1. It will be how much? It will be nearly 1, means you can say 0.9999, very close, correct? That's it, that it is. So sine cube when you are doing here, so it's cube if you are doing here, so cube will be also, it is slightly smaller than 1, so its cube will be also slightly smaller than 1 only, slightly smaller than 1. And then greatest integer it is, so greatest integer you will take of this quantity, so it is slightly smaller than 1, as I am saying here, it is smaller than 1, very negligibly smaller than 1. So what? It is a fraction. Smaller than 1 means 0.99. Slightly smaller means 0.99 something. 0.99 something means what here? Greatest integer will be what here? 0 only, no? So its greatest integer will be coming 0 only. So we can say this is nothing but 0 only. This quantity is nothing but 0 only. So just I am writing here this as limit x approaches towards pi by 2 sin x upon cos inverse of 0. Now on putting this limit pi by 2 on this, we will get here sine of pi by 2, which is 1 here, upon cos inverse 0, which is pi by 2. So from there we will get here 2 upon pi. 2 upon pi. So which option is correct here, everybody? A option is absolutely correct here. Next question is the value of limit x tends to 0, 140 to the power x minus 35 to the power x minus 28 to the power x minus 20 to the power x plus 7 to the power x plus 5 to the power x plus 4 to the power x minus 1 upon x into sine square x is equals to 2 ln k ln 7, then k is equals to what? So let's see it. So 140 to the power x, we can easily write down this as limit x tends to 0. 140 means 20 into 7 to the power x. So we can write down 20 to the power x into 7 to the power x minus this is 35. 35 also we can write down 7 to the power x into 5 to the power x right now. So 7 to the power x into 5 to the power x. And this 28 we can write down as 7 to the power x into 4 to the power x. So 7 to the power x into 4 to the power x. And similarly this 20 we can write down 4 to the power x, or we can write down this one as 20 to the power x only, then there will be no problem. Just write down it as 20 to the power x only right now, plus 7 to the power x plus 5 to the power x plus 4 to the power x minus 1, right, upon x sine square x. So from these two part, which two part? This one and this one, we can easily take 20 to the power x common here right now. So we are just taking 20 to the power x common here. So what is remaining here? 7 to the power x minus 1. 7 to the power x minus 1, right? And similarly, now you can see I can take 7 to the power 5 to the power x common with minus sign from this and this. So we can write down minus of 5 to the power x common. So that will become plus of 7 to the power x. And this is here minus of 1, since minus of 5 to the power x we are taking common, right? And similarly, from this one part and this one part, we can take common 4 to the power x. So minus of 4 to the power x. So that will become minus of 4 to the power x common. So that will be 7 to the power x. And that will be minus of 1, right? And also you can see from this two part, we can write down together as 7 to the power x minus 1 whole upon x into sine square x, right now, clear? And now similarly you can also write down this as from all these four terms we can take 7 to the power x common here. So 7 to the power x we are taking common, 7 to the power x minus 1 we are taking common, so the quantity remains inside is 20 to the power x. So 20 to the power x again we can write down as 5 to the power x into 4 to the power x right now, and this is a minus of 5 to the power x, this is minus 4 to the power x, and plus of 1 as it is, whole upon x sine square x, right everybody. So from first two part we can take easily common 5 to the power x, right? 5 to the power x we are taking common here, so that will becomes here 4 to the power x minus 1. So just taking here common 5 to the power x, so that will remains here 4 to the power x minus 1, everybody clear? And from these last two terms we can take minus 1 common here, so that will becomes here minus 1 if we will take common here, so that will becomes like this, right everyone, right now. And now from these two terms you can see 4 to the power x minus 1 is coming common, so it will remains 5 to the power x minus 1 into 4 to the power x minus 1. So just writing in simplified manner 5 to the power x minus 1 into 4 to the power x minus 1. So just like this 4 to the power x minus 1, right? Now here I am going to use some logic. That logic is using frequently used limit. One limit you have to observe, limit x tends to 0, a to the power x minus 1 upon x, that will be nothing but log base e a, right? So that is a frequently used limit that we are going to use in this. So just I am going to multiply this one's denominator by x, this one's denominator by x, this one's denominator by x, means we are multiplying x cube in the numerator's denominator, so denominator's denominator also we are multiplying by x cube, right? Now x into x into x is x cube, so here x cube multiplied, here also x cube multiplied, right? Using this frequently used limit we can understood this is nothing but ln 7 or log base c7, this is nothing but log base c5, this is nothing but log base c4, correct now? So this this will becomes here just I am writing, that will becomes here, you can observe that will be log base e of 7 into log base e of 5 into log base e of 4, clear? And in the denominator if you will see this x and this cube is cancelling, 2 it is coming here, so this is sine square x upon x square, so limit x tends to 0, sine square x upon x square means sine x upon x whole square, right? Now whole square, so limit will go inside using fundamental law of limit, so that will be that will be nothing but 1 only, so 1 square is 1 only, clear na? So using this we can say the denominator part is nothing but 1 only, so overall our answer is coming this only, clear? So this only, so from there we can compare it, so this is 2 ln 2 it is written, so ln 4 can be written log base c 2 to the power 2, so that 2 will be coming before, you can say here it is coming in, right, like this. So what it is now, you can compare 2 ln 2, that term it is, and 2 ln k, 2 ln 2 ln k and ln 7. So 2 ln 2 ln 7 is there, ln k means ln k is nothing but ln 5 only, correct now? So k is equals to what here? From this comparison we can say k is equals to 5 only. So k is equals to 5 is the answer for the given question, everybody clear? Next question is, let fx be a continuous and differentiable function satisfying f of x plus y is equals to f of x into f of y for all x comma y belongs to R. If fx can be expressed as f of x is equals to 1 plus x p x plus x square q x, where limit x tends to your px is equals to a and limit x tends to your qx is equals to b, then f dash x is equals to, so let's see. So the function is continuous and differentiable and satisfying this given relation, right? This given relation. So I'm just going to differentiate this functional equation with respect to x partially. So that will be f dash of x plus y. Since it is a differentiable already given, that's why I am doing differentiation partially with respect to x. So f dash of x plus y is equals to f dash x into f of y, clear now? And now I'm just going to put x is equals to 0 and y is equals to x. So that will becomes, on putting this, f dash of x is equals to f dash of 0 into f of x. Right, everybody? That we are getting here. That we are getting here. Now from here we can observe they are asking f dash x is equals to, so f dash x is this one, and that is equals to f dash of 0 into f of x into f of x. So f of x is nothing but this one only, correct now? Fx can be expressed like this, so fx is this one only, correct? And what about f dash 0? So that it is coming here. So let's see here. By solving this, if you are seeing this one, so that can be also written as nothing but f of x minus 1, f of x minus 1 is equals to, this is x px plus x square qx. So x I am taking common here and sending in cross multiplication denominator, and that will be px plus x qx. Right, everybody? That it is clear now. X we are taking common from these two parts. This one is coming on this side. So f of x minus 1, and that x we are taking common, cross multiplication denominator we are sending it, right now. And now if we will consider this functional equation, so in this functional equation I am just going to use here logically x is equals to 0 and y is equals to also 0, then we will find out what is the f of 0 value it is coming here. So we can see here, if we are putting this, so we are getting here f of 0 plus 0, f of 0 is equals to f of 0 into f of 0, so f is square 0, right now. So that is nothing but f square 0 minus f of 0, so f of 0 common here, f of 0 minus 1, it will remain here, is equals to 0, everybody. So f of 0 is equals to 0, we are getting here one thing, and f of 0 minus 1 is equals to 0 we are getting, so f of 0 is equals to 1 we are getting, second thing, clear now? So we are getting this. Now if we will consider this one part, which one part? This one part. So in this part, if you are going to put x equals to 0, so what will happen here, only you can see that will becomes here f of 0, x equals to 0 we are putting in this, so that will be f of 0 is equals to 1, and x will be 0, so entirely this is 0, x will be 0, so x square 0 into qx, so overall that will be 0, so f of 0 is equals to 1 we are getting. So f of 0 is equals to 0, not possible. F of 0 is equals to 1, it is possible, right now. So we can easily observe this, right now. Now f of 0 is 1, so can we say this one is nothing but, this one is nothing but f of 0 only? Can we say like this? Upon x minus 0, if I am writing any problem? No, is equals to px plus x qx we are getting here, right? That it is. Now if we are going to take limit x tends to 0, limit x tends to 0, clear na? Limit x tends to 0. So taking limit on both sides, limit x tends to 0. So what will happen? Limit x tends to 0. So here observe, that will be limit x tends to 0. So what will happen here? Just observe. This is f of x minus f of 0 upon x minus 0. This is nothing but it is indicating you derivability at point 0. This is nothing but derivability at point 0 here, correct na? So f dash of 0 it is, its meaning is f dash of 0 is equals to, if we are putting this limit here, so that is p of 0 plus 0 into q of 0, so 0 into q of 0, whatever 0 into it is, so overall it will be 0, no meaning of writing. So f dash 0 is equals to p of 0 we are getting here, right now. F dash 0 is equals to p of 0. So means limit approaches to, limit x tends to 0, so that is p of 0 it is becoming, correct now? Or you can say this is nothing but, you can say this is nothing but, in more simplified manner, limit x tends to 0, p of x it is, and this is here limit x tends to 0, x qx. So the thing is, this quantity will be exactly 0. Why? Because x is 0. X is 0, so overall in the multiplication 0. So we are getting this is nothing but that only, f dash x is equals to this. Now this value is already given, how much here? A. So this value is A only, so we can say f dash of 0 is nothing but A only, correct? So this one we can say directly that is nothing but A only. Clear everybody? We are getting this A only, clear? So f dash 0 is equals to A. So by this we can put this from here in this equation. So we are getting from here what? You can observe this data is becoming here f dash of x is equals to f dash of 0, which is nothing but A into f of x, right? Now that it is clear. And there x qx, on applying this limit, qx was already given. B is a fixed quantity, you know, and x approaches to 0, that's why I said that will be 0 here, clear? So f dash x is equals to A f of x. So which option is correct here? From there you can observe A option is absolutely correct here, right? F dash x is equals to A f x. Next question is, consider the function fx is equals to max of x comma 1 upon x whole upon min of x comma 1 upon x if x is not equals to 0, and fx will be 1 when x is equals to 0. Then they are asking, this is what here, where this is fractional part and this is greatest integer. Okay, so let's solve it. So at point 0 from left side, at point 1 from left side, and at point minus 1 from left side, limited value we have to calculate, right? So let's write down this fx. This fx we are writing at around the point 0, minus 1 and 1, correct? So we are saying that x is not equals to 0, then function is this. X is not equals to 0, then this. X is 0, then this, it will be there, clear now? So just observe here, when x is less than minus 1, so what will happen? When x is less than minus 1, I am saying less than minus 1. So just observe here, x is less than minus 1 means it is not equals to 0. So function is this one, correct now? So in this one, max operator in the numerator, x comma 1 upon x, x comma 1 upon x. Since x is less than minus 1, so less than minus 1. So in this case, x comma 1 upon x, which will be the maximum? 1 upon x obviously, upon min of x comma 1 upon x. So min will be what here? X is less than minus 1, that will be min, or x will be 1 upon x. Then which will be min here? X comma 1 upon x when x is less than minus 1. So min we are talking now, so obviously x only, so that it will be coming. So 1 upon x, so we can say 1 upon x square, everyone, 1 upon x square, right? And similarly, when x is equals to we want LHL only, no need to focus on the equality part. In between minus 1 to 0, on 0 also from left side, okay? So in between minus 1 to 0, if we are saying, in this one case again x is not equals to 0 na? So this one part only. So max we are observing, max among x comma 1 upon x, which one is max here? So just observe which one is coming max. So max is coming here x only, correct na? In the numerator x comma 1 upon x, which one is max? X only. And in between x comma 1 upon x, which one is min? So obviously x is max, so 1 upon x is min here, correct na? So 1 upon x means this x will be coming numerator, so x square, correct? So x square that it is, right everybody? You have to just focus on the number system. Negativity, magnitude more means value less, correct na? Along with the negative sign, more bigger quantity will be having least weightage, correct? And least magnitude of negative sign quantity will be called more weightage, so that is only there. And here when x is in between 0 to 1. So in this case again x is not equals to 0, not equals to 0. So in this case what it will be coming here? First one only part we have to focus. So among this, which one is max? X comma 1 upon x. Max we are observing, so 1 upon x obviously the max it is. Right now 1 upon x is max here. And then they are asking min, so 1 upon x is max, so x will be min obviously, so upon x. So upon x means that will become 1 upon x square. Like that. Clear everyone? That it is. Now we have to focus on these limits. So just observe here. Just observe this. Limit x approaches to 0 from left side. Means x is less than 0. It is approaching towards 0. From left side means it is slightly less than 0. Means negligibly less than 0. So less than 0. So which one part? This one part we have to observe. So what it is coming? X square. X square what? Fractional part it is. Right now? That it is. Plus limit x tends to 1 from right side part. 1 from left side part. So what will happen here? 1 from left side part if we are seeing here. So which one we have to focus? In between 0 to 1. From left side one, this one. So what here? 1 by x square fractional part. 1 by x square fractional part it is coming. Right? And next, limit x approaches to minus 1 from left side. Minus 1 from left side it is saying here. Right now. So what it is? Minus 1 left. Minus 1 from left side, this one part. So minus 1 less 1 by x square. Its greatest integer 1 by x square, greatest integer we are observing. Right, this it is. So what will happen here? Just observe. Just observe. So since x is just less than 0, it is coming. Just less than 0. Just less than 0 means it will be like minus of 0.00001, very close towards 0. Very close towards 0. I know so many zeros will be there. I mean to say, very close. This is x. It's a square if you will be doing here. So it will be what here? That will become negative quantity will become positive. It will be very close to again 0 only. Not 0, very close to 0 only, like this, correct? That it is coming here. Now, means very close to 0. This is very negligible quantity, very negligible, correct? Or neglect, I am saying. Negligible, neglecting value it is. So, its fractional part will be coming what here? Fraction part will be coming that one only 0 point of 0.000000000, very negligible. Neglecting, negligible, correct? Na? Negligible it is coming here. Negligible means what we can say? It is nothing but 0 only. Clear? This is nothing but 0 only. Clear? And now similarly, if you are focusing the second one part is what here? 1 upon x square when x is approaching towards 1 from left side. 1 from left side, everybody. So 1 from left side. So just observe here. 1 from left side, 1 by x square. X approaches towards 1 from left side. So you know now, 1 it is there. From left side it is approaching here. Left side means from this side. So you know that value will be what is 0.999999, very close towards 1, but not 1. Negligibly smaller than 1. Correct? So that it is coming here. And this is x here. Approximately. So 1 upon x square if we are talking. So 1 upon of this one's square. So it will be coming what here? 1 upon, that will be again it is coming here. Very close towards 1 only in the denominator. And very close towards 1 only. Very close towards 1 only. So when we, means its square is coming not 1. It's smaller, slightly smaller than 1. How much is the difference? Very negligible difference. Correct? So 1 upon of a quantity very negligibly smaller than 1. So whenever we are dividing it, it is coming. Since significantly we can say slightly it will be smaller, so it will be obviously dividing it. So denominator is slightly smaller than numerator. So it will be 1 point of something it is coming here. 1 point of something. Correct now? 1 point of something. But how much point of something? Very negligible. Very negligible here. Means you can say 1.0000000000001 kind of thing. Correct now? So its fractional part if we are seeing here, so that will be nothing but 0.00000000001 like that. Correct now? So its fractional part means this is negligible. I am saying what here? It is very negligible quantity. So it is negligible almost. Negligible. So what we can say negligibly it is quantity, we can say that is nothing but 0 only. Correct now? That is nothing but 0 only. And similarly if you will focus this one part, third one part, x approaches towards -1 from left side. -1 from left side. So -1 is there from left side. So from this side. So it means -1.00001. Very so many zeros, very negligible difference it is coming here. It is almost equals to -1, but from left side approaching. So what here? Minus 0.0000000, so many zero, and after then 1 2 something like this. No, 1 obviously, awesome. Very small it is. So now if you will see, this is our x. So it's a square if you are doing it. It's a square you are doing it. So its square will be what? This negligible, this negative sign will becomes positive here. And 1.001 square. 1 square is 1. It is slightly greater than 1. It is coming now. 1.0000001. Its square is what here? Very small quantity greater than 1. It is coming here. Correct? So it will be 1.0000. So many zeros. 1 you can say like that. Correct? So that is here x square part, right? So that it is, so it is in the denominator of 1. So 1 upon 1.00001. So whatever it is negligibly greater than 1 in the denominator part. So denominator is negligibly greater than numerator. So it will be coming. It is how much is the difference of numerator denominator? Very small difference. Negligibly denominator is greater than numerator. So if it will be also 1, so 1 upon 1 is 1, but it is not 1. Negligibly denominator is greater. So obviously the dividing result will be fraction, and what will be the fraction value? Very close towards 1. 0.999999, so many nines you can say after this. Correct? So its greatest integer now in this part we have to observe. Its greatest is 0.9999, whatever times of 9 is, it is written here. Its greatest integer will be what? 0 only. Hai na? Its greatest integer is 0 only. So third part is also 0 here. So this is also I can say moderate question if you will focus carefully on the number system. So you can easily find out the limit of this question, that is coming 0 only. So which option is coming correct among them? First option. First option is correct, everybody, right? Next question is limit x tends to 0 ln of cot of pi by 4 minus beta x upon tan of alpha x is equals to 1. Then alpha by beta is equals to. So let's solve it. So this one quantity, limit x tends to 0, and this ln of cot of this angle. So cot can be written 1 upon 10. So we can write down ln of 1 upon 10. So tan of pi by 4 minus beta x, and this tan 1 upon tan is cot here now. So tan we are writing it 10 to the power -1 we are taking. That -1 is coming here, you can see. Clear, everybody? So this minus this time taking outside of the operator here. That it is limit x tends to 0, right? And in the denominator it is tangent of alpha x, tangent of alpha x, right? So what will happen here? Just observe, minus of limit of x tends to 0, and then tan pi by 4 minus beta x we are going to solve here. So that is coming here ln of 1 minus tangent of beta x upon 1 plus tangent of pi by 4 into tangent of beta x. So tangent of pi by 4 is 1 here, tangent of beta x, right? Upon tangent of alpha x, right? So that it will be coming what here? Minus of limit of x tends to 0. That it is, and this quantity, if you are observing, I am just going to do here multiplication. I am just going to do here. Just observe this. Before multiplication, I am just going to add here 1 and subtract 1. So there will be no difference. So just I am writing here 1 minus of tangent of beta x upon 1 plus of tangent of beta x, and then here minus 1 plus 1 I am doing here, whole upon tangent of alpha x, right? That it is. Here one thing I am doing, alpha x in the denominator multiplying, alpha x in the denominator's numerator multiplying, no problem. Fundamental law of limit says that limit will come on this part, so tangent of alpha x upon alpha x, that is nothing but 1 only. You can understood very well, correct na? That will becomes here 1 only. So just observe, that will becomes here minus of limit x tends to 0. And this one part, if we will take here LCM, so you can observe this quantity LCM we are going to take here, this quantity. So that will become 1 minus tangent of beta x minus 1 minus of tangent of beta x. So that will be ln of minus of 2 tangent of beta x, right? And in the denominator 1 plus of tangent of beta x, right? Plus of 1, that it is. And this one denominator part already, as I said, limit x tends to 0, tangent of alpha x upon alpha x, that is nothing but 1 only. So we can say that is becoming this part using fundamental law of limit, that is becoming 1 here. So no need of mentioning that, directly we can write on alpha x here, right? That it is. Now one frequently used limit is the limit x tends to a, ln of fx plus 1 upon fx, that will becomes 1 if x tends to a, fx is tending towards 0, everybody, right now? So x is tending towards 0, so you know this part is becoming 0, correct? This will be 0, so this overall will be 0. Tangent of beta x, since x is 0, so tangent of 0, which is 0 only, so this overall part is 0. So this I am saying, if you are treating as fx, so fx plus 1 it is written. So what I am saying, to use this frequently used limit, this quantity denominator I am just going to multiply by this one and this quantity numerator also, correct? So meaning to say is limit minus of, just observe this, minus of limit x tends to 0. So ln of minus of 2 tangent of beta x upon 1 plus tangent of beta x plus 1 upon this quantity. Since this is fx already I said, to use this frequently used limit, I am just going to multiply this one's quantity denominator by this. So minus of 2 tangent of beta x upon 1 plus tangent of beta x, right? Now that it is clear. And alpha x in the denominator already is there. So what I am going to do, this quantity I am multiplying denominator, same quantity I will be multiplying in numerator. So just I am cleaning this, that I had shown, this I am going to use here. Same quantity in the numerator also multiplying. So minus of 2 times tangent of beta x upon 1 plus tangent of beta x, right? Upon this is alpha x, right? So this one quantity, as already I said, this one quantity will becomes here, this one quantity will becomes here 1 only, everybody. This one quantity will becomes 1 only. So 1 only it is becoming here. So you can see this is nothing but minus of 1. And this one part, if you are observing here, so what will happen here? Just observe minus of this. If you are seeing here, this one's quantity I am going to multiply. Limit is coming on this part. So beta x I am multiplying here. So numerator's denominator beta x multiplied. So here also I am multiplying beta x, right? So what will happen here? This one part, tangent of beta x upon beta x where x approaches to 0, that will become so 1 only, so minus 2. So that will become minus 2. And this one part if you are seeing here, 1 plus tangent of beta x, x approaches towards 0, so tangent of 0 is 0 here, so 1 only. So here you understood that is here 1 only in the denominator. And here x approaches to 0, so x is common here, get cancel here, alpha by beta it is coming here, alpha by beta here. So on simplified manner we can say this is coming nothing but minus and minus plus here, that is coming at 2 beta by alpha, that is coming at 2 beta by alpha here. So 2 beta by alpha directly we can write down 2 beta by alpha it is, right? 2 beta by alpha. So they are saying if this limit is equals to 1, this limit is equals to 1 here. So this limit is equals to 1 when we are using this. So alpha by beta. So you can see alpha by beta is nothing but 2 only. How? When we are using this cross multiplication. So alpha by beta we are getting here 2 only, everyone. 2 only. So 2 is the answer for this question. Right? Next question is, if alpha comma beta are the two distinct real roots of the equation ax cube plus x minus 1 minus a is equals to 0, where a is not equals to minus 1 comma 0, none of which is equal to unity, then the value of this quantity is this one, then what is KL? So let's solve it. First of all, let's solve this cubic equation. So here all the a terms together we are writing here. So a common here, x cube minus 1. X cube minus 1 we can write down that x cube minus 1 as a product of two factor, we can write down x square plus x plus 1 into x minus 1. And here if second part if you are seeing x minus 1 already there, so x minus 1 here and from here x minus 1 we can take common. So we can write down this into this one is equals to 0, right everybody? So this is a cubic equation, so 3 roots will be obviously there, and one of the root is coming from this factor x minus 1. So one root is coming, x is equals to 1. So one root is 1 only. So since in question is saying alpha beta are two distinct roots, none of which is equal to unity. None of which is equals to unity. So alpha beta, none of the root can be 1. So alpha beta root will be coming from this part alpha beta, right now. So let's solve this quadratic equals to 0 having two roots alpha and beta. So we can say that is written as ax square plus ax plus a plus 1 is equals to 0 here, right? So two roots alpha beta we are having here. So alpha plus beta is equals to minus of b by a. So that will be minus 1. As you can see, and product of root alpha into beta is c by a, which is a plus 1 upon a, right? This it is. This it is, everybody just observe this, it is coming here. So now we are going to solve this limit which is giving us this value. So let's solve this limit part. So in this limit part, limit x tends to 1 upon alpha, and this one quantity if you are observing here, so we can write down this is written here x cube plus ax cube minus x square. So minus x square here writing, this is plus ax cube minus a, so plus a we are taking common here. So what here, x cube minus 1, x cube minus 1 can be x minus 1 into same thing x square plus x plus 1, right everybody? Right now this it is coming here, and this it is x cube minus x square, we can take x square common, so x minus 1, x minus 1, x square we are taken common here, right, upon This one quantity e to the power 1 minus alpha x minus 1, and this it is x minus 1 here, right? So x minus 1, since it's a common factor in numerator denominator, just cancelling it, correct? We are getting this. And also one frequently used limit, we know limit x tends to a, e to the power fx minus 1 upon fx. That will be equals to 1 if fx is approaching towards 0. If fx is approaching towards 0. So x approaching towards a, fx is approaching towards 0, so that will be equals to 1 here. So we can see e to the power 1 minus alpha x, since x approaches towards 1 by alpha, so that will be also 0 here. So this is like fx here. So if this one's denominator, we are multiplying by this, and also in the numerator also this I am multiplying here. So any difference? No. And also now limit x approaches to 1 upon alpha, e to the power 1 minus alpha x minus 1 upon 1 minus alpha x can be written as 1 here using this frequently used limit here, correct? Now 1 minus alpha is our fx which is approaching towards 1 on applying this limit here. So this quantity is equals to 1. So I am just erasing this, that I had indicated you that I am using this frequently used limit. So that is coming 1 only, correct? Now that is 1 only. So limit x approaches towards 1 upon alpha. Now observe here, this becoming 1 here, this is 1 minus alpha x as it is written here, correct? And this one part, what is coming in the numerator, just observe, x square plus of ax square. So what here, x square common, a plus 1 is coming here, right? And a into x, which is ax here, plus a into 1, which is a only, right? From this in the numerator, if we are taking a common here, so limit x tends to 1 upon alpha, it is a we are taking common, so it is a constant not equals to minus 1 comma 0, so a is coming outside of this limit operator here, just writing it, right? And this one part is what here, a plus 1 upon a into x square plus ax upon a cancel x plus 1 upon 1 minus alpha x, right? Now everybody, this it is. Now if you will focus on the numerator part, if we are focusing, so just observe this a as it is, and this is limit x tends to 1 upon alpha, correct? This one part, this is a quadratic which can be written as a product of two factors, which can be using this relation between roots and coefficient, we can say as a product of two factor, 1 minus alpha x one factor and 1 minus beta x another factor upon 1 minus alpha x, right? That is correct. If you are doing product, you can observe it is giving you the same quadratic on using relation between alpha, beta and this constant and a. This quadratic only it is coming here, right? So now you can observe 1 minus alpha x on x approaches to 1 by alpha is what here? It is becoming 0 by 0 responsible form, just cancel them, correct? 1 minus alpha x was responsible for 0 by 0. Now applying directly this limit, we are getting here a into 1 minus beta into x, x is 1 by alpha, so beta by alpha, alpha is coming in cross multiplication, so alpha minus beta by alpha, so this it is, right? So from there you can observe what is L here. By comparison you can understood L is nothing but 1 only, L is nothing but 1 only. And what about K? K, if you are comparing here, so alpha coefficient, so K is what? And nothing but 1 only, that only, clear? So from there what we can say? We can say from there that K into L will be equals to 1 into 1, 1 only, Correct? 1 only. 1 only. So what is answer for this, guys? 1 only. 1 is the answer of the given question.